we know that we are going to have moment, right? And the moment is only in one direction. So we know that we are going to have so if I'm going to follow the transformation, okay, so if we were to follow the transformation of this diagram over here, this will be our x. This come on. So this direction, our x is coming up. So our y is going upwards, and this is our z. Okay, and this is we have our rotation in the x. Why I drew it this way? Because I'm following the transformation over here. If you don't do that, you're messed up whether are you going to take ixx or iyy. Okay, so you get confused. So follow the transformation based on the diagram down here. It is safer. Okay, I'm not saying that you have to do it always, but it's safer that way. Okay, so we know that stress.
Wait, sir.
Yes.
If we follow the transformation instead of z, shouldn't we have x?
Yeah, but x is coming out, right?
Oh,
If
okay, okay, okay. Got it. Yeah.
right, right. Okay, right. So we know that under this structure, we know that stress z is equal to mx over ixx multiplied by y, right? We know that. And then the shear, right? We also have a shear is equal to Vy over Ixx Qx divided by T, right? For this case, because it's wide flange, we have to do thin wall analysis. Now the question is this, okay? So if we were to sketch, okay, if we were to sketch the distribution of our form of our analysis, okay? So I'm going to sketch the. Okay, so hey, what happened now? To apologize. All of a sudden my OneNote disappear. Okay. So now if we'll go to sketch, right? So if we were to sketch our bending moment diagram or our bending load, okay? So this is our axis. Okay, so this is our y, right? So this will be our okay. So if we were to sketch, so under normal stress, right? We know that under normal stress, okay, this is just a sketch. We will have one diagram looking like this. Okay, so from here, right, and this, no, there's no eccentric loading, so I have to. Okay, so we know that this is based on stress Z is equal to mx over ixx multiplied by y. We know that. And then if we look at the shear stress, okay, I'm only going to sketch the shearing stress in the flange. Okay, I'm only going to do the shearing stress on the flange because it's thin wall analysis. It's not thick wall. Okay, So this is where the flange is. Right? So this is also correspond, I'm going to draw one more trend. And I'm going to call this our shear. Okay? And we know the shear, right? I know this will not be 0. Okay? It will probably look like this. And this over here is for Vy. It's going to Vy over Ixx Qx multiplied by T. Now, question for you. If you look at the I-beam or the white flange, where is it going to fail? Anyone? Gajinder and Lux, that's all we have. The failure will occur here. Okay, failure can you tell me why? Failure will occur at the junction of the flange and web. Any idea why?
Because you have the most shearing and you have no support to stop the failure at that point.
No, it is because it's controlled by the fillet radius. Okay, the fillet radius is a stress concentration. Okay, stress concentration point. Okay, so for 3AO3, right, I'll need to teach you how to calculate the stresses of the structure excluding the effect of fillet radius. Right, so for 3AO3, you do normal and shear stress distribution by not considering the effects of stress concentration. Right, so you will only learn about stress concentration in 3EO5. Okay, in 305, then stress concentration factor will be considered. So you are going to look into how different fillet radius will have different coefficient for stress concentration multiplier. Okay, and the stress concentration multiplier is all experimental based. Okay, it's like fluid mechanics, right? You have Reynolds number based on different pipe diameter, for example, and flow velocity is exactly the same thing. Okay, so for today, I'm going to stop over here. Anyone, any question before I let you go? No? Okay, so today, again, the main emphasis, okay, is on design of the transmission shaft, okay? It's easy, Okay, the difficult part are two things. Okay, one, you have to get the forces in the right direction. Two, you have to know how to calculate your what? You have to know how to calculate your moments and your torque. Okay, you have to know how to calculate your moment and your torque. If that's the case, thank you both for your time. Okay, I'll see you guys on Thursday for tutorial. Thank you. I'll still stay behind if you have any other question. Okay.